assistant professor in the University of McGill, is a cognitive neuroscientist, and it has been a long time that we haven't been here in Cafelitt, and we're happy that you're here tonight.
Shabbat Bakher. Good evening, everybody. I'd like to start by again thanking my friends here for making this opportunity to present this talk. I've been talking about this idea for a number of months with Pasha, especially in the light of recent developments in the movie industry and the emergence of 3D technology in home theater systems. Well, we said together, why don't we just see what can be done in terms of bridging the gap between what's available out there and what we need to relay to our audience to understand how this thing takes place. And that thing is basically perception of 3 dimensions that emerges from very rudimentary input to the visual system. So by way of just laying out an outline for tonight's talk, I have basically 3 points that I want to go over. How can we see far into the distance based on the flat image on the retina? If you don't know what the retina is, I'll explain to you, and that's a very simple component of the visual system. Why do we see depth better with 2 eyes than with 1 eye? If you've ever noticed how the world looks with just 1 eye open, if you go to the doctor and he puts an eye patch on you, or something of that sort, then you'll see a qualitative difference between your perception of the visual world with 1 eye as opposed to 2 eyes. So we're going to get to why depth perception is better with 2 eyes. And lastly, I'll spend about maybe 10-15 minutes talking about how depth perception relates to these emerging segments of the entertainment industry. So the problem that I want to propose to you, which is a very serious problem from a computational perspective, is how do we get from here, the real world, well, this is not really the real world, real world itself on 2 dimensions, but imagine you're looking at the screen, you're looking at whatever is between you and the screen, and you have a very good sense of where everything is, without really having to think about it, without having to do any computations or any mental effort. You open your eyes, what happens immediately is that an image of the world, what's in front of your eyes, gets cast on the back of the eye, which is the sensitive film called the retina. The retina is where the magic of vision, so to speak, takes place, where the energy of light is transduced into a pattern of electrochemical signals, and from there, those signals exit the eye through these exit holes, if you will, and find their way into the brain, into the visual cortex, and things happen at that level, which make you able to see. But before we get to any of those things, the question is, well, the problem is, out there in the world, there are things that are near you, there are things that are far from you, and it's based on at least the 3-dimensional physical structure of the world. There are things, objects that occupy at least 3 dimensions of space. And as a result, they could be placed in at various distances from the viewer. Sometimes one could be in front of, or partially in front of something else. And it's a really easy thing to obviously see and appreciate and coordinate our actions with. But as I said, the problem is it doesn't really start that simple. What happens right off the bat is that the 3-dimensional structure of the world gets collapsed onto 2 dimensions. You get a 2-dimensional flat retinal image. And from that, which is the raw material for the rest of your visual system, from that you have to extract enough information to be able to represent the visual world in a reliable, realistic way, so that you can act upon it accordingly. Otherwise, there is no use for perception. particularly that of 3D. So this is the problem that we start with. An inverted, flipped image of the world, which is two-dimensional in nature, which has no depth information obviously or readily available. So is the belief, right? When you look at this two-dimensional image, you say, well, I've lost the third dimension. How is it that I can represent it if it's not there to begin with? And the answer is, well, if you look closely, all the information you want is actually embedded in that retinal input or in other ways by the visual system. And that's what I'm going to talk about for the maybe first half of the talk. Walk you guys through the steps in which that are required to extract these pieces of information, these signals, from the visual world, and then use it to reconstruct the world in our minds, so that this third dimension, depth, is readily available to us. Okay. So, as I said, there are signals that are embedded either in the image or they become part of the visual, part of the processing of visual image. One of them, or a class of them, come from basically the way in which the apparatus for vision moves. So we can move our eyes voluntarily by looking here or there and so on, or sometimes involuntarily by just deciding to look at a close object, which makes us maybe look silly like this, and strain our eyes in order to focus on something that's closer to us as opposed to something that's farther away. Right? So this is what the eyes of a person look like normally when they're looking at a distance. This is what it looks like when they're looking at an object close by. And you could try this on yourself, or maybe look at your neighbor as they're doing this. So you bring your thumb close to you, and then you look like your eyes are going to just pop out or something. But what this all means is that, or what this whole behavior is significant is for providing the brain with information from the muscles that are controlling the eyes to move in those particular ways, involuntary, convergent, or divergent ways. So the motor system gives feedback to the brain as to where the eyes are looking. And that's a good signal, if you will, a very rudimentary but good signal to sort of figure out if you're looking at something that's close to you versus far away from you. So even without having any visual input, there is information going to the brain from the muscles telling the brain where you're looking at, right? So you can make the distinction between a close object and a far object. So that's sort of an index of depth, right? The distance of an object to the perceiver. So on top of that, as you're moving your eyes this way or that way, depending on where you're looking, things are happening to the lens inside the eye, inside each eye. So if you're going from a far fixation point, looking at a far object, to a near fixation point, looking at a close object, what happens is that automatically the lens, as you can see in these three slides, goes from a very relaxed state to a very, if you will, condensed state in response to the basically the